Trigonometry Assignment by Mo. Let's start off with the basic skills. Well, in this presentation you will learn all the trigonometry that you are likely to remember in 10 years, assuming that you are a lazy, non-curious, lifelong learner. When labeling a right angle triangle, you must always look at the reference angle. In this case, 23.6 is the reference angle. The opposite side is always the opposite of the position of the reference angle. Like you can see here, this is the reference angle. The opposite of it is always the opposite side. So this is the opposite side. The hypotenuse is always the opposite of the 90-degree angle, which is this one, because this is the 90-degree angle and this is the opposite. And then last but least is the adjacent, which is always behind the reference angle, which is here. This is the reference angle, so the adjacent is supposed to be there. Let's do some examples together. So, we know this is the reference angle, so this would be the opposite. We know this is the 90-degree angle, this would be the hypotenuse. Oh, sorry, all the way. And then, this is the adjacent, because it's behind the reference angle. Same thing here. This is the hypotenuse, the opposite, adjacent. Makes sense, right? Let's do some examples together. I have a couple examples that we can do together. We know that this is the 90-degree angle, so B would be the hypotenuse. C would be the opposite reference angle is always the opposite. So this is the opposite, and then this is the adjacent. Hypotenuse, opposite, adjacent. Hypotenuse, opposite, adjacent. Hypotenuse, this is the opposite, this is the adjacent. Hypotenuse, this is the opposite, and this is the adjacent. You'll just get used to it. It's really easy. Hypotenuse, opposite, and then adjacent. Before we start with Sokoto, I got some jokes. So, where does Mr. Ali go on vacation? She goes Times Square. Why did it divide 10 by 10? Just cause. Why did the 2 4 skip lunch? They already ate. 4 is my bad. Alright, so now let's move on to Sokoto. Sokoto is a method that is used in mathematics to remember the definition of 3 most common trigonometric functions. I'm not going to explain this picture just because I'm going to be explaining it in the next slide. So, the steps. Figure out which part of Sokoto you'll need to use. Well, if we have the opposite or the hypotenuse, we'll have to use sin, which is opposite divided by the hypotenuse. If we have the adjacent and the hypotenuse, then we'll have to use cos, which is adjacent divided by the hypotenuse. And then, last but not least, which is tan. If we have the opposite and adjacent, it will be opposite divided by the adjacent. So let's do this problem together. So we have to find the indicated angle for this image. So let's just see what we have first, right? So we know that we have the hypotenuse and we have the adjacent, which is always behind the angle. So we have the hypotenuse and adjacent. So that means hypotenuse and adjacent. So we're doing cos. So we have the hypotenuse and the adjacent, which means we will use cos to find the reference angle. So cos equal adjacent divided by the hypotenuse. Cos equals 6 divided by 12. Cos equals 0.5. And then cos negative 1 times 0.5, which will give us 60 degrees. Sin law. The law of sins provides a formula that relates the sides with the angles of a triangle. This formula allows you to relatively easily find the side length or the angle of any triangle. The formula is A divided by sin A equals to B divided by sin B equals to C divided by obviously sin C. So like sin B, sin A. So let's try solving this. Well, we have to solve triangle for PQR in which P equals 63.5 and angle K equals 51.2 degree and R is 6.3. So first we calculate the third angle. So angle 3 equals 180 degree minus 63.5 degree minus 51.2 degree, which is equal to 65.3 degree. 6.3 divided to sin 65.3 degree equals to P divided to sin 63.5 degree. P 6.3 sin 63.5 divided by sin 65.3 equals 6.297 really. And then correct to 2 decimal places. It's correct. 6.3 divided by sin 65.3 equals to K to the sin 51.2, and then K equals to 5.40. Next, we calculate the slides. angles of R is equals to 65.3 degree. P is 6.21 centimeter, and K is 5.40. Sorry. So now let's move on to cosine line. There are two cases for using the law of cosine. When you know two sides and the included angle, we can use it, and want to find the third side. Or when you know three sides and want to calculate any angle. This is the law of cosine. A squared equals b squared plus c squared minus 2bc times cos A, and then it goes on. Well, we have this problem. In M, C equals 42 degree, A equals 19, and B equals 26. We have to find the length of side C and the nearest integer. So we know we have some of the sides, and we have one reference angle. So what I did c squared, which is equal to a squared plus b squared minus 2ab and cos times cos c. So I did c squared, and then I got the 19 squared and the 26 squared minus 2.19 2 times 19 times 26 times cos 42, which is equals to 302.7729, and then it's square rooted. I had to square root because we have the exponent, which equals to 17.400. Yep, so it's equals to 17. So the side C, the length of side C is equal to 17.17. You can just 17.4. So now let's move on to the extended question. For the extended question, I'm going to be handing it in class. And before I end this video, I just want to wish Miss Shirley a happy Christmas. And yeah, so thank you for listening to my assignment. Merry Christmas.